Multipath TCP is particularly useful in multipath data center and mobile phone environments. All mobiles allow you to connect via Wi-Fi and 3G networks. Multipath TCP enables either the combined throughput and the switching of interfaces without disrupting the end-to-end TCP connection. For example, if you are currently on a 3G network and you have an active TCP stream, the TCP stream is bound to that particular interface. If you want to move to the Wi-Fi network, you need to reset the connection, and all ongoing TCP connections will therefore get reset. However, with Multipath TCP, the swapping of interfaces is transparent. Next generation leaf and spine data center networks are built with Equal-Cost Multipath. Within the data center, any two endpoints are equidistant. For one endpoint to communicate to another, a TCP flow is placed on a single link, not spread over multiple links. As a result, single path TCP collisions may occur, reducing the throughput available to that flow. This is commonly seen for large flows and not small mice flows. In a data center, when a server starts a TCP connection, it gets placed on a path and stays there. With Multipath TCP, instead of using a single path per connection, you can use many subflows per connection. If some of those subflows get congested, you just don't send over that particular subflow, improving traffic fairness and bandwidth optimizations. The default behavior of spreading traffic through a lag or ECMP next hop is based on a hash-based distribution of packets. An array of buckets is created, and each outbound link is assigned to one or more bucket. Fields are taken from the outgoing packet header, such as the source destination IP address or MAC address, and a hash based on this endpoint identification. A bucket is selected by the hash, and the packet is queued to the interface that is assigned to that bucket. The problem with this approach is that this load balancing algorithm does not take into account interface congestion or packet drops. With all mice flows, this is fine, but once you have a mix of mice and elephant flows together, your performance will for sure suffer. An algorithm is needed to identify congested links and then reshuffle the traffic accordingly. A good use for Multipath TCP is when you have a mixture of mice and elephant flows. Generally, Multipath TCP does not improve in performance for environments when you only have mice flows. With small files, Multipath TCP offers the exact same performance as regular TCP does. However, as the file size increases, Multipath TCP usually has the same results as link bonding. The benefits of Multipath TCP come to play when you have very large file size. At this level, Multipath TCP outperforms link bonding, and the congestion control can efficiently balance the load better over a dispersed amount of links.